Hi guys, this is problem number 2 in section 9.3. In this problem, let's take a look at this problem. At a certain company, passwords must be from 3 to 5 symbols long and composed of 26 uppercase letters of the Roman alphabet. The 10 digits 0 to 9 and the 14 symbols like these symbols. Now, the first question is how many passwords are possible if repetition of symbols is allowed? So, in other words, when you have three symbols, 4 symbols, 5 symbols, let's discuss this, right? So it's either 3 or 4 or 5 symbols long. So it's going to be all. We are going to add all these results together. So when it is 3 symbols long, because repetition is allowed, there are 26 letters to choose from and 10 digits to choose from and 14 symbols to choose from. In other words, the first character can be one of those, right? So 26 plus 10 plus 14, which is 50. So you can choose 50, one from the 50. So basically it's just like 50 choose one. And then the second character, because repetition is allowed, you can choose any one from this 50 and so on and so forth. For the third one, you can choose one from those 50. So therefore, this basically is 50 times 50 times 50, which is 50 cubed. Okay, and similarly, just use the same idea. How many ways to form a password? If repetition is allowed when it is 4 symbols long, it will be 50 raised to the 4th power. And by the way, again, this is or, it's either or, so we are going to use addition rule. So the last one will be 50 raised to power 5, right? Okay, so with calculator, actually this is supposed to be 318,875,000 possible passwords. Now let's take a look at the second one. How many passwords contain no repeated symbols? Again, let's discuss those, okay? Let's discuss like for the 3 symbols long scenario. So 3, right? So the first one, you can choose any one from those 50. But once that one is chosen, you cannot choose it again. So therefore, you're left with 49 symbols available for you to choose. So 49 choose 1 for the second one, right? So similarly, after those 2 symbols are chosen, you cannot choose any one of those for the third one, which means you're left with 48 symbols to choose from. So it's going to be 48 choose 1. So that's this means 50 times 49 times 48. Okay, so therefore that's for how many ways to form a 3 symbols long password. Now for the 4, that will be 50 times 49 times 48 times 47, right? And for the 5 symbols long, that will be just 50 times 49 times 48 times 46, and then so sorry, it's not 46, 47 and then times 46, right? So there are 1 2 3 4 5, yes. Okay, so this is for the part B, and actually if you do the arithmetic, I actually had that available now. This is 259,896 and 896,000 possible ways to form such passwords, like no repeated symbols. Now, part C says how many passwords have at least one repeated symbol. So at least one. So we the passwords contain like two possibilities for all the passwords. So first group is no repetition, right? No repeated symbols. It's either that or at least one repeated, right? at least one repeated symbol. So those are the possible passwords. It's either that or that. Now we have found this many from the part B. This is actually the part B results, right? And the total is actually the part A results. That's all the possible passwords. So in other words, when you add these two, you get the total possibility, which is this result, right? All possible passwords. Passwords. Now, this is like 318,875,000, and this is 259,896,000. So when you subtract this, then you will get this one. So therefore, the answer is, so for part C, it will be this guy minus this guy, right? So that's what's gonna be the result. Okay, so therefore this actually turns out to be 58,979,000. Okay, and that's at least one digit is repeating. The last one is, what is the probability that a password chosen at random has at least one repeated symbol, which is what's the chance of getting a password like in C, right? So therefore, the chance will be whatever the number of password that has at least one repeating digit divided by the total, which is this guy there, right? Okay, divided by this. So it actually turns out to be around 18.5%. Around 18.5%. All right, this is the hints for 9.3 number 2.